Hello 8th graders. In this IXL video we're going to be taking a look at cluster Y and the first assignment in cluster Y, that's the one find the slope of a graph. So before we dive into this assignment, the big thing we need to understand is slope is another term or another word that means rate of change. And specifically, if you do your rate of change with the Y variable or the rise on the top and the X variable or the run on the bottom of the ratio, then that ratio for rate of change is called slope. So again, slope is always rate of change, but specifically measuring how much does the y change in the numerator divided by how much the x changes down in the denominator. So the big key, if I'm going to measure slope and I have a graph, the biggest thing I need to do is to find two data points that are good and easy to use on the graph. And I'm going to go ahead and mark two of those data points right now. When I'm looking at this line, I look for two data points that are clearly on corners of a grid box, easy spots to use. So I'm going to use this spot right here that starts right on the 2 and on the x-axis, and I'm going to keep following the line until it hits the corner of a grid box again. Right here I see it hits that nice corner perfectly. So now with these two purple data points, I can start measuring from this first point to the second one, how much did I rise, the y change, compared to how much did we move sideways, the x change. And here we see, if I draw this out, we're going to use a red color and we're going to draw a quick little arrow up there. And we see it climbs up by 5 units. The first thing that I see or recognize here is that the purple dot, from the first purple dot to the second one, I have to climb straight up by 5 units from 0 to 5. And then we also need to climb sideways, but just a little bit. It's going to be hard to see, but that little blue line there represents our sideways movement. And because it only moved over one grid box, and each grid box is worth 1 unit, we climb up by 5 and right by 1 here. So that tells me my rise is 5, the y gains 5 units, and each time the y gains 5 units, our x value gains 1 unit. So our slope is 5 over 1. They ask us to simplify. I'm not sure if they'll take 5 over 1, so I'm going to test that. We could simplify 5 over to 1 to just be a slope of 5, but let's see if they take 5 over 1. Cool. So I think they would have taken either one there. When you have something that divides to a whole number, I like to keep it as a ratio, but feel free to bring it to that whole number, that integer. Okay, next problem. 1 second to clean the screen up. Same situation for this whole assignment. It's about finding slopes, so you need two data points. So I'm going to look here on my graph, and I'm trying to find one good data point, and we see right here where I'm putting this blue dot is one data point. Let's make that a little bit bigger. And then as I keep following this graph here, I see another data point right there. And these are the two data points I'm going to use that I marked in blue. And very quickly here, we'll use a red arrow to represent how far we're climbing up our y change. It's only a little bit, you see. And then we'll use a blue arrow to represent the x change, how far we're running sideways. So we see here I climbed up by 1 unit. Switch to red here quickly. We climb up by 1 unit, so that's our y change. And when this graph for this line climbs up 1 unit, it runs sideways by 3 units. I go from the 2 here over to the 5. So in this graph, each time the y climbs up by 1, the x runs to the right by 3 units. So our slope, our rate of change, our rise is 1, and our run is going to be 3. Thanks for being patient there. So there's our slope. It's 1 over 3. I'm going to go ahead and plug that answer in here. A big key to understand, you don't necessarily put the larger number on the top. I think a common mistake here would be for students to put a slope of 3 over 1 because it's easier to do 3 divided by 1. If I do 1 divided by 3, I get a decimal. But it's important to understand for slope, for our rate of change, we care about how quickly the y grows for every one x. So it always has to be y change on the top, x change on the bottom. We're going to show one more example quickly, but I think at this point you should certainly be able to go do this on your own, but we'll give you one more example just in case. So, same situation, this whole assignment is just can you find the slope of a linear graph that's not proportional? So I'm going to find 2 data points. We're going to mark those up. We'll pick orange, different color today. So here's 1 data point. Oop. Right there, we're going to put a dot in orange, and then we're going to keep following this graph until we have another one. I could stop here, but I'm going to pick a further data point, and we'll prove it. It doesn't matter which 2 data points I pick. At the end, it'll always simplify to be the same slope ratio. So here's my first data point. The second one I chose is a bit further along. I chose this other data point up here when x is 8 and y is 7. And I'm going to go ahead and figure out what is the rise, the y change, versus the run. So here we're going to measure with this red arrow the rise, how much we're moving up, and then with this blue arrow we're going to measure how much we're running, the x change, how much we had to move sideways. And we see for the rise, this red arrow, I could count each grid box, or I could know we go from 1 on the y-axis up to 7. And 7 minus 1 equals 6. So rather than counting all 6 grid boxes, I'm just using the number line, the coordinate plane, to know from 1 to 7, we've gone up by 6 units. Same thing for the blue, the run, the x change. I see it starts out at 5 on the x-axis, and it's going to finish at 8. So I know this is a jump of 3 units, or I could count 1, 2, 3. So we'll put the plus 3 there to represent the x change, or how much we ran sideways after we rise, or the y gains 6 units. So our slope here is going to be 6 over 3. And I'm going to go ahead, and we know 6 divided by 3, which we'll put in down here, 6 divided by 3 can simplify. It's actually the same thing as 2 over 1. So I'm going to simplify 6 over 3 to 2 over 1. And if you wanted, you could even go further and say the slope is just 2. But I like to always leave my slope as a ratio, so for now I'm putting in slope as a fraction for this assignment. If you need any help with this assignment, please feel free to reach out to me. Of course, my email is ddoherty3@Boston Public Schools, but you already are familiar with that, so please, if you're ever stuck on an IXL assignment, send me a message. I'm happy to jump on live and help you out. Keep up the great work.